Welcome to PPL Expert. My name is Tom and I'll be presenting the Flight Performance and Planning course. This course is designed to give you an in-depth understanding on the theory required to pass the CAA theory exam for this particular topic. Despite this, own self-study, commitment and discipline will be required. The course is displayed in the form of a slideshow which I'll be talking through. Please feel free to pause the recording at any point to either take a break or write down any notes. So the first topic we're going to look at is the airworthiness of an aircraft and all the documentation which is required to certify this. So the first document we look at is something called a type certificate. And once an aircraft has been built and it's passed all the relevant tests for it to be certified, it is granted with a type certificate authorization. It's granted by airworthiness director, such as EASA in Europe or the FAA in America, and this airworthiness certificate or type certificate is issued to the manufacturer for this particular type of aircraft. We have a certificate of registration, and in the UK, planes must all be registered, so they'll have a registration on the side and possibly under the wings as well, just like you would register a car and its number plate. So it's a way of identifying a particular aircraft. We must have the registration displayed on the aircraft and have a copy of the certificate of registration inside the aircraft as well. And this certificate is one for every particular aircraft. So each aircraft will have its own registration, and depending on the countries they're in, it'll have a different kind of registration. For instance, in the UK, all registrations start with the letter G for golf, but other countries such as France will be F for foxtrot, so different countries have different starting letters. Next, we're going to be looking at a certificate of airworthiness, and this certificate is issued to each aircraft and it is non-expiring. And what it is, it's a certificate to say that the aircraft has been kept up in its maintenance schedule in accordance with the flight manual and the governing body of how often it needs to be maintained. Every category of plane, so no matter its purpose, whether it's for transport or aerobatics or every different kind of aircraft and its category, is subjected to quite a lot of forces in flight. So the flight manual will depict how an aircraft should be flown. It gives it structural limits, and long as these are kept within limits and the certificate of maintenance is kept into date, so the aircraft has been maintained regularly within its limits, then we'll get a certificate of airworthiness to state that the aircraft is fit for flying. So each aircraft will have something known as a flight manual, or it can otherwise be known as a pilot operating handbook. And that contains all the information for each individual type of aircraft. So each aircraft will have one, and it's all the information that we may require. If we want to know a bit of information about a particular aircraft, we can find it in the pilot's operating handbook. It's made by the manufacturer of the aircraft, so it's all their recommendations for standard practices, from weights till takeoff distance and all those kind of things. The aircraft documents, including the flight manual, must be carried on board an aircraft. If we're flying to a different airfield, the only exception is if we're taking off and landing at the same aerodrome, we don't have to carry the pilot's operating handbook or these other documents with us in flight. So as I said before, the flight manual or the pilot's operating handbook includes all information we need to fly the plane. Okay, it's split into different sections. So we've got a general section, a limitation sections, again, emergency procedures, how to deal with them, normal procedures, performance, the weight and balance calculations. You can see any kind of way of operating the aircraft will be listed in the flight manual. So all aircraft, no matter their purpose, yes, are subjected to a strict maintenance schedule. And usually a typical maintenance schedule will include an annual inspection, so every calendar year, a 100-hour inspection, or possibly 150-hour, but 100 is more common. So for every 100 hours the aircraft flies, it will undergo an inspection. A 50-hour inspection, uh, or 6 months, whichever's first. So if it flies 50 hours, then it will have an inspection. But if 6 months comes before that, so we haven't flown 50 hours within 6 months, it will go into a 6-month inspection. And then obviously daily pre-flight inspections to check the condition of the aircraft. So you can see that aircraft are subjected to a lot of maintenance to make sure their airworthiness at all times and pick up any defects quickly before they progress into something more serious. These schedules are done via the CAA, so they make the recommendation of when and how often an aircraft should be maintained. So a LAPL or a PPL license holder may carry out minor repairs and services according to the air navigation regulations, providing the aircraft concerned weighs less than 2,730 kilograms. So minor repairs are generally just changing the oil and any main cosmetic things that aren't they're not going to affect the structural integrity of the aircraft itself or damage the aircraft in such a way that it may be a hazard. So it's just basic things that we can do with a license. So we've had a look at how often the maintenance schedule happens, and the aircraft will be issued with a certificate of maintenance review, which is issued every 12 months for aircraft with a mass less than 2,730 kilograms. Once an inspection has taken place or some kind of maintenance, the aircraft will receive a certificate of release to service, which is issued after every inspection. So it's saying that the aircraft is being released by the mechanic and is therefore okay to fly. The technical log, and every aircraft has one, which records all the times of flying and any defects, is kept in inside the aircraft or it could be on a digital form, so a spreadsheet, but it needs to be readily available so we can record the times of flight, how often, and then by recording the times of flight, we know how often or how soon we need to do any maintenance scheduling, and if we see any defects on the aircraft, so any issues, that can also be reported in the technical log as well. So as I said before every pre-flight, before every flight, we do a pre-flight inspection, which is the first flight of the day. Now, after every subsequent flight, it's still important to do some kind of inspection to make sure that the aircraft hasn't been damaged through flight. But at the start of the day is when we do the most thorough one. And what we're looking for is we're just checking the overall condition of the aircraft, that it hasn't been damaged through the night, maybe it was left outside. We're checking all the fluid levels, so the oil, the fuel, making sure we've got enough fuel for flight and oil for flight, making sure the tyres are pumped up. So it's a general condition overview to see if we have any defects which may be a hazard to us. Now, this daily pre-flight inspection is normally in the front of your checklist, and it will give you a walk around of all the things to check in the morning to make sure the aircraft is serviceable and ready for flight. So here's a list of a couple of other documents that need to be carried within the aircraft. So legally, we need to have a noise certificate, a weight and center of gravity schedule, so they'll weigh the aircraft and see where the center of gravity lies, so we can work out the mass and balance for when we add fuel and other cargo. An aircraft radio license to say that the radio is serviceable and of the correct kind, and also aircraft insurance details. And we need to have all these documents inside the aircraft. As again, if we have a ramp check, so somebody comes out to the aircraft and asks to see these documents, if they're not available, then we could obviously be in trouble. So part of the pre-flight inspection in the morning will be to check that all of these documents are not only available, but also in date. Okay, they do have an expiry date, so making sure they're all valid before we go flying. Now each aircraft will have a structural limitation or a mass limitation. So it's the maximum amount of payload we can put in an aircraft and it's still being safe to fly. Okay, and it does have this weight put on a placard, and it will give us the maximum ramp weight, so the weight before we start taxiing. It will give us a takeoff weight as well, so the maximum weight before takeoff, and a landing weight. We could also receive some performance limitations like temperatures of operating the aircraft, particular pressures or runway conditions, and if these change, then that may affect our performance, which we need to be aware of to make sure that we still got enough performance to carry out the task in hand. Okay, so abiding by these limitations will prevent us from getting in a situation where the aircraft is outside of its structural or performance limitations. So we spoke about mass limitations. So here's a couple of terms. Now, part of the mass and balance checks, or when they put the aircraft for maintenance, they will weigh the aircraft. So they'll put it on a set of scales and read the actual weight of the aircraft. And by doing this, they can work out how much weight we can therefore put in the aircraft, and then that can change our performance. So here's a couple of terms that we need to know. So the first one is MTOM, which stands for maximum takeoff mass, and that's the absolute maximum weight that the aircraft must be in order to take off. So it can't be any heavier than this point to take off. We have the maximum landing mass, which is the maximum weight of the aircraft on landing, and normally it's governed by the strength of the landing gear, which cannot take any more weight than this amount. Then we have the maximum zero fuel mass. So that's the maximum weight of the aircraft, including passengers and cargo without any fuel inside. And again, it's a structural limitation to make sure that we don't break anything inside the aircraft or out. So we need to abide by these limitations and make sure we're within these limits. Again, it's a safety factor, making sure that we're not putting the aircraft under more physical stress than it needs to be. So many aircraft and airframes have some kind of limitations. So it could be an aerodynamic limitation, such as that the stall speed or a low speed limit, so the speed the aircraft's actually flying. It could be a power limitation, so we might only be able to operate a certain power for a certain amount of time. Or it could be a structural limitation, so we might not be able to operate the flaps above a certain speed, or we might not be able to operate a certain speed for too long, depending on what these limitations are. So we need to again abide by these limitations and make sure we stay within them so we don't overstress the aircraft and then it's not subjected to failure. Okay, and if we do start operating outside of these limitations and we were to have an accident, our insurance would be invalid because it will be stated in the pilot's operating handbook not to operate outside of these limits. So it's important that we abide by that. So first of all, we'll look at some speed limitations, and this is an ASI known as an airspeed indicator, and there's some different speeds that we need to be aware of not to overspeed an aircraft or not put it in any danger. Now the way an airspeed indicator works will be covered in aircraft general knowledge. We're just looking at the limitations. So you can see it works in a clock kind of fashion. As we go faster, that dial turns in a clockwise direction. So at the lower end of the spectrum, if we fly too slow, we could get near the stall speed, and that's the speed at which the wing will stall and then not create enough lift to fly the aircraft. So we don't want to get below that